This is Circular Functions Part 3, and of course there'll be more parts to this as we continue along on this discussion. But I was talking to you guys the last time about having an S prime and a regular S. Okay. Now the regular S is an arc that goes around the circle. Let me go ahead and show this to you. Okay, we're going to say that this line S here starts right here at the diameter of the circle, or even the radius here, and it goes all the way past the 90-degree mark, and it comes over this side. Okay, so it starts at the diameter of the circle, goes past the 90-degree mark, and continues onward, but it does not extend past the diameter again. Okay, now then, what we want to do is anytime a line like this extends above the 90-degree mark, we've got to find a positive number so we can find numbers like sine, cosine, and tangent. It's easier to find sine, cosine, and tangent of an arc if the number is positive. Otherwise, you got a lot of work to do, and we don't want you to do a lot of work. So we invented this special little arc called S prime, and the measure of S prime is the measure of pi, because remember, if you draw an arc from this part of the diameter to this part, okay, if you draw an arc between this side of the diameter and this side, that's pi. Okay, so what you're going to do is you're going to subtract pi. You're going to subtract this S arc, okay, from pi, and that will leave a little tiny segment which is called S prime. And you're going to use S prime to find your sines, your cosines, and your tangents. Alright? Now then, so S prime, now how do we know that something's called an S prime? Okay, you have the letter S here, and then you have this dash right here, and that's called S prime. So in this case, S prime. Now, how do we know that this number is going to be pi? Well, if you substitute the number 1 here, 2 times 1 is 2, 2 minus 1 is 1, and 1 times pi is pi. So it's pi minus S, okay, minus this great big arc S, will leave you with S prime. And S prime is a positive number. That's how they come up with all that. Alright, now let's say we extend S all the way past the diameter here and go into what is called the third quadrant. Now you remember the Cartesian coordinate system? It has quadrants. Quadrant 1, Quadrant 2, Quadrant 3, and Quadrant 4. Quadrant 1 means that all x and y values are positive. Quadrant 2 means that all y values are positive, but the x values are negative. Quadrant 3 means that all the y values are negative, and so are all the x values. Okay? And then Quadrant 4 means that all the y values are negative, but all the x values are positive. Alright. Now, let's say we extend S here to quadrant number 3. And in quadrant number 3, all the x and y values are negative. We still need positive numbers. How are we going to achieve that? Well, we're going to create something called an S prime. S prime is equal to, now, you see that N right there? We're going to put a 1 there. 1 times 2 is 2. 2 minus 1 is 1. There's pi. So we're going to have the arc S minus pi, and whatever's left over is going to be S prime, and it's going to be positive. So basically, we're snipping away at the original S. We're going to take off all of its stuff from quadrant 2 and all of its stuff from quadrant 3 and leave only what was in quadrant 1. Alright, let's say S extends all the way into the fourth quadrant but doesn't quite make it to the diameter. Okay, so what we're going to do, let's say that N is 1. 1 times 2 pi is 2 pi, so we're going to have a circle subtracting whatever we have in S, and that will leave the positive value. And that's how that works. Okay? And hopefully you got that. If you didn't, leave a comment down here below. I will tell you more in a future video, so stay tuned.